We will finish up the presentation of CSEC Multiple Choice Practice Paper 1 by presenting Part D. The sides of a parallelogram are 12 centimeters and 5 centimeters. If one of its diagonal is 13 centimeters, then its area is, well, anybody who is on top of his geometry will realize that the area is 12 multiplied by 5, which is equal to 60 centimeters squared. And of course, that is option B. Well, if we are on top of our geometry, it should not take us any long period of time to determine the answer. With all this information, how should one be expected to solve the problem in 3 seconds? Let us take a look at how, if you are on top of your geometry, you should be able to solve this problem in 3 seconds. The examiner expects you to know that 12, 5, 13 is a ratio of the sides in a right-angled triangle. This will cause the parallelogram to be a rectangle, and we know that the area of a rectangle is equal to length multiplied by width. So there we have our rectangle and the sides of a parallelogram. We are just saying that it is rectangle because we know for sure that it is rectangle. Not only that, we will prove in a short while that the parallelogram is actually a rectangle. So the sides of a parallelogram are 12 centimeters and 5 centimeters. So we'll put those right there. Its diagonal is 13 centimeters. So put the diagonal in, it is 13 centimeters. The purpose of the information that tells us that the diagonal is 13 centimeters is to cause us to realize that the triangles of course are the two halves of the parallelogram. So the purpose of including the 13 is to cause us to realize that the triangles are right angled, and it does not play any further role in determining the area. So to tell us that the diagonal is 13 is just to cause us to realize that each half of the parallelogram, as we have them right there, that each half is represented by a right angled triangle. And of course 13 will play no further part in determining the area of the parallelogram, which turns out to be a rectangle. So there we have the two halves, of course, separated by the diagonal. The diagonal is 13 centimeters, and we have 12 centimeters and 5 centimeters. And we are saying that the angle here is a right angle, and also the other one right there is a right angle. Therefore, we will have two right angled triangles. But we will not take that for granted that we have two right angled triangles. We will also show that the two triangles are actually right angled. The area of the rectangle is the length multiplied by width, and of course 12 multiplied by 5 is equal to 60. So we have 60 centimeters squared. No problem with that. On the next slide, we will prove a few things. The first of which is that each component triangle is right angled, causing the parallelogram to be a rectangle. So we will prove that the triangle is actually right angled on the next slide. Considering the upper triangle, of course both of them are equal, so we may as well consider any one of them. So considering the upper triangle, although they are both identical, its two short sides are 12 centimeters and 5 centimeters. So let us use Pythagoras' theorem to prove that the hypotenuse, which is the longest side, will actually turn out to be the diagonal of the parallelogram. That is, it is actually equal to 13 centimeters. So we have two sides, 12 centimeters and 5 centimeters. We are going to use them with Pythagoras theorem and show that the result is actually 13 centimeters. So we have the algebraic representation of Pythagoras theorem right there, and we will substitute the length of the two short sides of the triangle that we are speaking about. So we have these are the two short sides. Of course, this one is the hypotenuse. So we will substitute the values of the two shorter sides into the formula. Of course, we have a squared plus b squared. We will end up with 5 squared plus 12 squared. We may say 12 squared plus 5 squared. Does not matter. So 5 squared plus 12 squared. And then, of course, 5 squared is 25. 12 squared, 144. There we have them. And 144 plus 25 will give us 169. The square root of 169 we know to be 13. Therefore, this triangle adheres to Pythagoras theorem. Because it does, we are sure that it is right angled, because only right angled triangles will adhere to Pythagoras theorem. Let us take a look at the difficulty that we would have had to go through if we did not realize that the parallelogram is actually a rectangle. So we still could have found the area, but we would have to go through some serious difficulty. Not really very difficult, but it will be at least time consuming. With the sides and the diagonal of the parallelogram given, we are able to determine the area of one of its constituent triangles, which is, of course, half of the area of the parallelogram. So we have the parallelogram, say we did not know that it's actually a rectangle, and we have the two sides here and the diagonal. Therefore, we will have 1, 2, 3, all three sides of the triangle. And of course, there's a formula that we may use in determining the area of a triangle if we have all three sides. Let us move merrily to the formula that is used to determine the area of the triangle if we know all three of its sides. S is equal to a plus b plus c divided by 2. We usually refer to that as the semi-perimeter. So we add all of the sides and divide by 2. The sides are 12, 5, and 13. So we are going to have 5, 12, 13, and we will divide by 2. What do we have? 5 plus 13 is 15. 5 plus 12. 13 plus 12 is 25, and 25 plus 5 is 30. So we will have 30 to be divided by 2, which is equal to 15. The semi-perimeter is 15, and we will use that S semi-perimeter in the other formula. So area is equal to the square root of all of S, then multiplied by S minus A, then multiplied by S minus B, then multiplied by S minus C. That means we are going to take the semi-perimeter, which is 15, then we subtract one side from it, the other side from that, and also finally we subtract the third side. We will no doubt make our substitution right there. So we will have 15 is the semi-perimeter, then we'll have 15 minus 12, then 15 minus 13, then 15 minus 5. And we will end up with 15 multiplied by 3 multiplied by 2 multiplied by 10. We may do this quite easily. 15 times 2 is 30. And 3 times 10 is 30. So we have 30 multiplied by 30. So we are sure that the square root will turn out to be 30, because we have there 30 multiplied by itself. But 30 multiplied by 30, we may say the area is equal to the square root of 900, and the square root of 900 will turn out to be 30. So that turns out to be the area 30 centimeters squared. But what is that the area of? We have just calculated the area of one of the triangles, half of the area of the rectangle. So the area of the triangle that we have just calculated is actually half of the entire parallelogram. So in order to determine the area of the parallelogram, we will multiply that 30 by 2. So the area is equal to 30 multiplied by 2, which is equal to 60 centimeters squared. And that is what we have right there as our answer. The diagram shows a cylinder of radius 3 centimeters and height 8 centimeters. The volume in centimeters cubed is, we are going to determine the volume of that cylinder. To find the volume, we will make use of the following formula. V is equal to pi r squared h. Do not forget that a cylinder is a prism with circular cross-section. The area of a prism is equal to the area of the cross-section multiplied by the length, or in this particular case, the height. And of course, the length or the height is expected to be perpendicular to the cross-section. So we have circular cross-section. The area of a circle is pi r squared. And of course, we need to multiply by the length, or in this particular case, the height, which is h. So the volume is equal to pi r squared h. Area of cross-section multiplied by length. That is the volume of a prism, the formula for the volume of a prism. The volume of the cylinder turns out in this particular case to be this, because we have the area, cross-sectional area of the prism, which is the cross-section of the cylinder, which is actually a circle, right here, and we are multiplying that by the length or the height in this particular case. Pi r squared h. So we have made our substitution. R is 3 centimeters, so we square 3 by multiplying it by itself, and we have 8 right here. So take note that pi is present in every single one of the options. So we have the options containing pi in every single case. Therefore, we have not substituted a numerical value for pi. So pi is there in every option. We do not substitute a numerical value for pi. We may proceed to find the volume. So there we have it. A is equal to 72 pi centimeters cubed. Of course, we do not need to have the centimeters cubed right here, because we have the statement the volume in centimeters cubed is, so we are sure that the volume is already in centimeters cubed, so we need not include the centimeters cubed at the end as it pertains to the options that we have right here. But of course, in the answer that we have calculated, it is appropriate to have the centimeters cubed right there. The correct answer is option C. There we have an algebraic expression, and we need to determine what it is equal to. All that is required in solving this problem is for us to expand the brackets and combine the like terms. We'll begin by expanding the brackets. So let us expand the brackets first. So what do? We say 5 times 2x, and that is equal to 10x. Then we continue with the 5 times a negative y. We have negative 5y. Move to the next product. Negative 2 times 3y. We have negative 6y. And of course, negative 2 multiplied by negative 5x, we will have a positive. See, negative multiplied by negative is equal to positive. We will have a positive 10x right there. Let us combine the like terms, if any. Of course, we can identify like terms right there. So 10x plus 10x will be equal to 20x. That goes there. And of course, if there is any set of other like terms, we may combine them in like fashion. And we do. Negative 5y minus 6y. Do not forget that whenever we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So we have them having the same sign, so we will add them and the answer will take the same sign as the numbers that we have added. So we have a negative 11y right there. The correct answer is option D, 20x minus 11y. What is the simple interest on $150 for 8 months at 2.5% per annum? We will use the regular formula for calculating the simple interest. The only concern, and not a serious one at that, is the mixed number that is given as the rate. So simple interest is equal to principal multiplied by rate multiplied by time. And I know what some students or candidates are saying right now. Where is the divide by 100? The rate is a percentage, a fraction with 100 as its denominator. Dividing by 100 is therefore a redundancy. As long as the rate is included, dividing by 100 is mandatory. Including 100 in the formula is just a bad habit that we have developed over the years. So the simple interest is actually equal to principal multiplied by rate multiplied by time. Do not forget that the rate is a fraction whose denominator is 100. Therefore, the denominator of 100 is already included in the rate. Now we are going to take a look at the 2.5% rate, which is actually 2.5 divided by 100. There is your 2.5%. Let us first write it as a single fraction. And what do? Of course, we will take 2.5 and make it into an improper fraction. And by so doing, we will have the result 5 over 2. As usual, 2 multiplied by 2 is 4 plus 1 is 5. So we will have 5 over 2. So 5 over 2, or 5 divide by 2. Dividing by 2, then dividing by 100 is the same as dividing by 200. So we have 5 divide by 2, then divide by 100. That is the same as dividing by 200. So we will have 5 over 200 as our rate that we will use in our calculation in a minute. So we have the formula there for simple interest again. and the principal is $150. The rate is 5/200. And time being equal to 8 months may be converted to years by dividing by 12, because the time is given in months. Some students may not realize, or even realizing will be negligent, not considering the fact that the time is given in months, and they go merrily along treating the 8 as if it is 8 years. But we need to be cognizant of the fact that 8 is actually 8 months. So being 8 months, to determine the number of years or the portion of the year, we will divide by 12. So the time is 8 divided by 12. And there we have our fractions that we will no doubt reduce as quickly as we can. The fractions may be reduced by a common factor of 50. 50 into 200 is 4, and 50 into 150 is 3. Anything else? Right. We may have a further reduction by a common factor of 8, in which 4 and 12 in the denominator are taken together as 48. So 4 multiplied by 12 is 48. So we'll take these two together and we will reduce them by 8. So 48 divided by 8 is 6, and of course 8 into 8 is 1. Yes. 3 is the final common factor that we have. So 3 into 3 is 1, and 3 into 6 is 2. What do we end up with? 5/2. We are left with a nice and familiar result, 5/2. Initially, we converted 2.5 to 5/2. We are therefore sure that 5/2 is equal to 2.5, or in decimal, we have 2.5. The correct answer is therefore $2.50, and this is represented by option A. What is the amount received when $500 is invested for 2 years at 6% per annum compound interest? The answer is immediately $561.80, and this should be determined without having to make a stroke of rough work. So we should be able to look at it and say, there we go, 561.8 or $561.80. Right. And that we should be able to do without even starting to do any rough work. How so? The two small figures are automatically out because we need the amount received. So the amount received, not the interest received. So we need the amount received, not the amount of interest received. The amount received will be inclusive of the principal, which will cause only C and D to be worthy of consideration. So the amount received will be all that you have invested plus the interest. So of course we know that A and B cannot be inclusive of the original amount or the principal, so they are automatically out. So we will consider only options C and D. Increasing a number by a particular percentage will reduce the number of trailing zeros, or in the case that we do not have any trailing zeros, increase the number of decimal places. So that is the effect on a number if we increase it by a particular percentage. What? The number of trailing zeros will be reduced, or we will have an increase in the number of decimal places. We may even have both a reduction of the trailing zeros and an increase in the number of decimal places, as we have in this particular case. We may expect such an occurrence when we are increasing or decreasing by a particular percentage repeatedly, as is the case when compounding interest or depreciating values. So we will expect an increase in the number of decimal places or a reduction in the number of trailing zeros, and no doubt, depending on the circumstances, we will have both of them, increase in the number of decimal places and reduction in the number of trailing zeros. We will next demonstrate how the number of trailing zeros and eventually the number of decimal places are affected by increasing by a particular percentage. So let us look at it. Let us subject $10,000 to a 15% increase for 3 years compounded annually. So remember that increasing by 15% will cause the original, that is 100%, to increase its value to 115%. That is what we always do. Increasing by a particular percentage, we add that percentage to 100. We end up with 115. 115% is actually 115 divided by 100, and that will give us 1.15. Therefore, increasing by 15% is equivalent to multiplying by 1.15. After the first year, let us multiply by 1.15 and see the result that we get. So we have $10,000 and we multiply that by 1.15. Notice how many trailing zeros we have? 1, 2, 3, 4 trailing zeros. Now how many do we have? 2. Right. And that is after the first year. After the second year, what do we know? We now do not have any trailing zero when we had 4 to begin with. So we see that increasing by a particular percentage has the tendency to decrease the number of trailing zeros. What do we know? After the second year, no trailing zero. Next, we will expect an increase in the number of decimal places. So we are going to do that for a third year and see what happens. Right. So at the end of the third year, we have 2 decimal places. So what do we know? We have a diminishing of the trailing zeros, and we have now an increase in the number of decimal places. That is what will happen if we increase by a particular percentage, and that is the effect that it will have on the figure that we are increasing by a particular percentage. There we have it, an increase in the number of decimal places. That is why I was able to just look at the options and identify the correct answer without working it out. In a multiple choice examination, all of the answers are there. It may be that working out is not necessary. Sometimes the examiners expect us to use our knowledge and just common sense. So if we use knowledge and common sense, we may be able to determine an answer without actually working it out in a short period of time. No, if it were not a multiple choice problem, we would have to work it out. But in a multiple choice problem, all of the answers are there. By looking at options C and D, remember that A and B are out. So A and B are out, so we are just considering C and D. It is option D that has the level of distortion that we would expect in the trailing zeros if interest is compounded twice. Right, so it is option D. See, notice that we had this to begin with, and if we are increasing by a particular percentage twice, we would expect that the trailing zeros would be diminished, and not impossible to have an increase in the number of decimal places as we have right here. So because we realize that the trailing zeros diminish in this particular result, and we are at the point where we have an increase in the number of trailing zeros, we are sure that this one is the correct answer, and that is what we would expect when we are increasing by a particular percentage, especially when we are doing it repeatedly, as in the case of compounded interest. The Venn diagram gives information on students who are studying home economics, mathematics, and art. Which of the deductions can be made? And of course, we are not going to summarize them because we are going to take a look at each of them individually. Now, the first statement, which says some students who study art study home economics. The first statement is not correct, as the set of students who study art is entirely enclosed in the set of students who study home economics. This is showing us that all students who study art, not some, all study home economics. So we realize that since it is entirely enclosed in this set, we are sure that all who study art, not some, study home economics. We are sure that the first one is incorrect. What about the second one? No student who studies art studies mathematics. The second statement is true. The set of students who study art and the set of students who study mathematics are disjoint. That means they do not have any element in common. They do not have any element in common. So we are sure that the statement is correct. No student who study art studies mathematics. What about the final one? Some home economics students study mathematics. The third statement is true. The set of students who study mathematics and the set of students who study home economics have an intersection. They have elements in common. That tells us that they share elements. So some of those who study home economics study mathematics, not all, because none of the set is enclosed in the other. So we know that it is some, not all. Therefore, we know that the second and the third are correct. So 2 and 3 only are correct, and that is represented by option C. Statements 2 and 3 are correct. The correct answer is option C. A regular hexagon is inscribed in a circle as shown. The radius of the circle is 7 centimeters. The difference in centimeters between the perimeter of the circle and the perimeter of the hexagon is, and we are going to do our calculation. If I could not solve this problem, I would guess that because both figures appear to be close in their perimeters, the difference between them would be small, and choose 2 as the answer. Well, 2 is the smallest one, but I am hoping not ridiculously small. If it is not 2, then it is actually 7. But I opted to go with the smallest one because the perimeters are close to each other. So if I could not solve the problem, that is what I would choose. Now let us proceed to solve the problem. Any line segment going from the center of the circle to the circumference is the radius of the circle. This means that all of the triangles in the diagram are at least isosceles, with the equal sides being the radius of the circle. So this is the center, this is radius, this is radius, this is radius, this is radius, and so on. So we are sure that each triangle will have at least 2 sides equal, which will make it at least isosceles. The angle of a revolution is equal to 360 degrees. At the center, it is divided into 6 equal parts. Don't forget that the hexagon is regular, so it is divided into 6 equal parts. Each angle at the center is therefore equal to 60 degrees. So we have a revolution of 360 degrees, and we have 1, 2, 3, 4, 5, 6 of them. Therefore, we are sure that each angle at the center is 60 degrees. So we have two facts. The angle at the center for this triangle and for the others is 60 degrees. And we are also sure that these sides are equal. So the triangles each will at least be isosceles. So there we have our 60 degrees, indicating that that is what we expect for every single triangle at the center. Any triangle with two equal sides separated by an angle of 60 degrees is not only isosceles but also equilateral. We'll prove this later, of course. This makes all of the triangles equilateral, and all of the sides of all of the triangles are equal to the radius of the circle that we know to be 7 centimeters. Right. So the triangles are isosceles. Further, because this angle here is 60 degrees, then the triangles are also equilateral. That means all of the sides are equal. So if this is 7, this is 7, the triangle being equilateral, this must also be 7. So all of the sides of all of the triangles will be equal to 7 centimeters. And if all of the sides of all of the triangles are equal to 7 centimeters, we will have 7, 7, 7, 7 all the way around. The perimeter of the hexagon is easily calculated because it has 6 equal sides of 7 centimeters each, as we have demonstrated on the previous slide. The perimeter of the hexagon is 7 multiplied by 6, which is equal to 42 centimeters. The perimeter of a circle is its circumference. Right, so let us find its circumference. The perimeter of a circle is its circumference. Let us find its circumference. So C is equal to 2 pi r. So there we have the values of pi and r substituted in the formula. The 7's will cancel, and 2 multiplied by 22 is 44 centimeters. So the 7's will cancel, and we'll only have 2 multiplied by 2, 44 centimeters. The difference between the two of them is 44 minus 42, which is equal to 2 centimeters. So of course the difference between them, we subtract one from the other and we end up with 2 centimeters. And of course that is the choice that we had in the first place. This shows that I was correct in the first place. That is how much it pays to use your common sense. I always tell my students that common sense is greater than mathematics. On this slide, we will use another method to show that each triangle is equilateral. The total internal angles of a polygon is given by the formula 180 multiplied by n minus 2. N is the number of sides of the polygon. To find the size of each angle, we divide by the number of them. So we will have 6 angles and 6 sides. So to find the size of each angle, we will divide by the number of them. So this will give us the total of the interior angles of the polygon. Therefore, to find the size of each interior angle, we will divide by the number of sides, or the number of angles. Right, so this will give us the total of all the interior angles, and to find the size of each one, we will divide by the number of them. In this particular case, n is equal to 6. Right, so n is equal to 6, so we will have 180. In the bracket we will have 6 minus 2, and of course we will divide by 6 in the end. So we have 180 that we divide by 6. If we divide 180 by 6, we will get 30, and 6 minus 2 is equal to 4. So we will have there 30 multiplied by 4, and that is equal to 120. So the size of each interior angle will be 120 degrees. Each internal angle of the hexagon is therefore equal to 120 degrees. Like that. So one internal angle or interior angle. The hexagon is regular. Each radius bisects an internal angle. All subdivisions will be 60 degrees. We already know that the angles at the center are equal to 60 degrees. All of the angles in the triangles will therefore be equal to 60 degrees. They will all be equilateral, that is, all of the triangles will be equilateral. So we have the internal or the interior angle 120 degrees. This line will bisect the interior angle, so we will have 60 degrees here, 60 degrees over here, and it will be true in every single case. So this is 60, this will be 60, this will be 60, all the way around. We will have all of those angles equal to 60 degrees. Therefore, in each triangle, we know already that the angle at the center is 60 degrees. Therefore, in every single triangle, all of the angles will be equal to 60 degrees, and that is what we have in equilateral triangles. Therefore, all triangles are equilateral. Here is a simpler way to prove that each triangle is equilateral. The angle of revolution is equal to 360 degrees. At the center, it is divided into 6 equal parts. It is divided into 6 equal parts because the hexagon is regular. Each angle at the center is therefore equal to 60 degrees. So we have 1, 2, 3, 4, 5, 6. So the entire angle of revolution, 360 degrees, will be divided by 6. Each one will be 60 degrees. Each triangle is isosceles because each has 2 sides that are radii of the circle. So those 2 sides are radii of the circle. Therefore, we are sure that the triangle is isosceles. In an isosceles triangle, the 2 equal angles are opposite to the 2 equal sides. One angle is 60 degrees. The rest of 180 degrees will be shared between the other 2 angles. So this is the triangle that we have. We are sure that because this side is equal to this side, then this angle is equal to this angle. One angle is equal to 60 degrees, so the other 2 angles will be shared equally. So 180 minus 60, that is equal to 120. 120 divided by 2 is 60 degrees. That means each one of those will be 60 degrees also. So we are sure that the triangle is equilateral. In a triangle with all angles equal, all sides are equal. It is therefore equilateral. So all angles are equal, therefore all sides are equal, so all of the triangles are equilateral. As a matter of fact, this one that we are highlighting is equilateral, and all the others will be similar to it, so all of them will also be equilateral. Mr. Smith's weekly salary was increased from $210 to $280. His assistant's salary was increased in the same proportion. If his assistant's salary is now $200, then the assistant's salary before the increase was, what do we say? The key word in the statement of the problem is proportion. That is the key word, proportion. The word should not be confused by the word amount. It gives the impression of percentage increase or increase by a particular fraction of the original. So, we are thinking of a percentage increase or an increase by a particular fraction of the original, not an increase by a particular amount. So I imagine that what some students will do is this: 210 to increase to 280, the difference is 70. They look at the assistant's new salary and they will say, take 70 from this, I get 130. Bingo! And that would have been the incorrect answer. So Mr. Smith's increase is, let us look at his increase, 280 minus 210, and that is Mr. Smith's increase, and that is by $70. But his assistant's salary did not increase by the same amount. Not necessarily. It was increased by the same proportion, the same fraction, the same percentage. Now, we are just using our common sense to make a quick calculation. 70 is 1/3 of the original. The original is $210. So $70 is 1/3 of the original. The original may be thought of as 3 portions of $70 each. One portion is $70, and that is added to the original. So if we have the increase is $70, so 210, which is the original, is 3 times 70. Therefore, the amount that we increase 210 by is actually 1/3 of 210, because 70 is 1/3 of 210. So we have increased that by 1/3 of the original. We have found 1/3 of 210 and we add it to 210, then we get 280. So the original may be thought of as 3 portions of $70 each. One portion of $70 is added to it. Now we have 280 will turn out to be what? 4 portions of 70. So $280 will turn out to be 4 portions of 70, because what? We have 210, which is 3 portions of 70, and we add another portion of 70 to it. So now we have 4 portions of 70. So that is what we have. What do we do then? The assistant's new salary should therefore be considered to be what? 4 portions also. So 280 is actually 4 portions of 70. Therefore, we know that the assistant's salary is 4 portions. So each portion will be, the new salary is $200 for the assistant. Here it is, and it is 4 portions. So one portion will turn out to be 200 divided by 4, and that will give $50. But we know that just like Mr. Smith's, the assistant's salary was 3 portions before, but this time 3 portions of $50. Therefore, we have 50 multiplied by 3, and that is equal to $150. Let us do a little recap of it. We need to know the increase. We subtract 210 from 180 because it is increased from 210 to 280, which is 70. 70 turns out to be 1/3 of 210. Therefore, we can consider that the 210 is actually 3 portions. So it is 3 portions first, and it was increased now by another portion to 4 portions. Therefore, the assistant's salary has 4 portions. So we divide the 200 by 4 and we get 50. The original amount was 3 portions, so we multiply that by 3 and we end up with $150. And that's the correct answer. The correct answer is option C. Let's take another look at it. The problem may also be solved by using ratios. In this case, the ratios will be written as fractions with some order. We just don't write down. We make sure that we use some order. If we do not use order, then we'll have the entire thing in disarray and never come to the correct answer. And no doubt, we will have distractors there that contain our wrong answer, as we have shown before, and we will be sure that we are right when we are quite wrong. The initial amount will be the numerator and the final amount will be the denominator. The increase were by the same proportion. Therefore, the ratios and hence the fractions will be equal. So we are just using this fraction initial over final to indicate that we will always put the initial over the final. So for Mr. Smith, the initial is 210, the final is 280. So there we have it. And also the initial for the assistant we do not know, but we do know the final to be $200. So we have 210 over 280 and we have x over 200. Since we have this fact that his assistant's salary was increased in the same proportion, so we know that the two fractions are equal. Right. The equation may be transposed to give, and we will transpose that equation and we get 280x is equal to 210 multiplied by 200. And of course finally we say, since we are multiplying by 280 here, we divide by 280 on the other side. That is what we have right here, and the fraction may be reduced by a common factor of 70. Quickly, 70 into 280 is 4, 70 into 210 is 3. No doubt 4 will go straight into 200 how many times? And 4 into 4 1 time. So 4 into 4 is 1, and 4 into 200 is 50 times. So finally we will have 3 multiplied by 50 is equal to $150. The correct answer is option C, as we have determined during the first take at solving the problem. So we may use ratio, we may use just plain common sense, as we have done before. The pie chart shows the choices of 180 boys for their favorite game. How many boys preferred football? The alert candidate will be able to look at the data and determine that the correct answer must be 50. Right. So if you're alert, you look at the circumstance that you have there and you know that the answer is 50 and that you may do in less than 3 seconds. It should immediately occur to you that 180, which is the total number of boys, is half of the angle of one revolution, which is 360 degrees. This implies that the number of boys who preferred football should be half of the value of the angle associated with football. So 100 divided by 2 is equal to 50, and we end up with our answer like that. So let me just take a second, go at it. This 180 is the total number of boys, and the total angle of one revolution is 360. So the total number of boys is half of the angle associated with one revolution. Therefore, the number of boys that you are going to have who choose football will be half of the angle associated with football. So we will be able to see that in less than 3 seconds. No problem. 180 was chosen by the examiner, most likely with this in mind. If candidates can read the examiner's hand or mind, which they should learn to do, life can turn out to be quite easy. On top of that, candidates should be ready to pounce on every opportunity provided by the occurrence of any loose number, such as we have in this particular case. So, when we see loose number in a problem, we should just jump at the opportunity to make use of them, like we have just done. The way that we have learned to solve this problem from primary school days is to determine the fraction of the entire revolution that is represented by football, and that will be done by dividing the angle associated with it by the angle of one revolution, and the angle of one revolution 360 degrees. We will therefore divide the angle associated with football, which is 100 degrees, by 360. Right. We then proceed by multiplying that fraction by the total number of boys, because it is a fraction of the total. We multiply that fraction by the total number of boys. And what do we know? The fraction may be reduced by a common factor of 180 very quickly. 180 into 360 is 2, and into 180 is 1. Then we say 2 into 2 is 1, and 2 into 100 is 50. So there is your 50. There is the answer that you have sought for by a method that you are familiar with, and in good time at that. So it is done in a short period of time by using our old method. But I would just look at it. 180 boys, we know that the angle of one revolution is 360. We know that that is half. So we just take half of the angle that is associated with football. Then we know that our answer can be obtained in a matter of seconds. The pie chart, which shows the choices of 180 boys for their favorite game, if a boy is chosen at random, the probability that he likes table tennis is? What is the probability that he likes table tennis? The pie chart, which shows the choice of what? 180 boys, and it shows the choice of their favorite game. And what do we say? The probability that the boy likes tennis. No, of course, it does not matter how many boys we have in the entire sample or the entire population. That does not matter. What matters is the fraction of the entire amount that table tennis represents. So, to find the probability, we divide the number of events that will give a favorable outcome by the total number of events. So, what is the number of events that will give a favorable outcome? Those who play table tennis will give a favorable outcome. The angle associated with this is 60 degrees. Right. It says the probability that he likes table tennis. So those who like table tennis will give a favorable outcome, and it is represented by 60 degrees there. And then now, finally, the angle associated with the total is the angle of an entire revolution. So we need to divide that by the total possibility, and it is possible for us to choose a student or a boy throughout the entire pi, which is of course represented by an angle of revolution of 360 degrees. And of course the fraction may be reduced by a common factor of 60. 60 into 360, 6. And 60 into 60, 1. The fraction is therefore 1/6, and that is represented by option D. So the correct answer is option D. There we have it. The rate percent at which $1,200 is invested to gain $72 in simple interest in 3 years is, so we need to calculate the rate percent in this particular case. This is another simple interest problem in which the simple interest is already given and we need to find the rate. We have discussed in a previous problem that including 100 in the formula is a matter of redundancy because the rate is already a percentage. So let us write down the formula for simple interest, which is I. I is equal to principal multiplied by rate multiplied by time. Making R the subject may be achieved by dividing the left hand side by PT. So there we have PRT on the right hand side. So R is in fact being multiplied by P and also being multiplied by T. To make R the subject of the formula, we will therefore divide the left hand side by PT as we have it right here. Then of course we will take the R and make it the subject by placing it on the left hand side, and the other expression is placed on the right hand side. There we have the values. P is 1,200, T is 3, and I is 72. Those will be substituted into the expression, and that is the result that we have, which we will of course reduce by common factors beginning with 24. So we say 24 into 1,200 is 50, and 24 into 72 is 3. There we have 3 as common factors, and we'll no doubt reduce by a common factor of 3 also. The answer turns out to be the fraction 1/50th. Since rate is expressed as a percentage, we will go back to primary school once more, where we learn to write a common fraction as a percentage by multiplying by 100. We have a common fraction 1/50th, which we will multiply by 100, and that will give 2%. 1/50 multiplied by 100. 50 into 100 is 2, and that's all there is to it. The correct answer is option B, no doubt. The transformation that maps the point P, 0, 1 onto its image P prime, 3, -1 is a rotation of 180 degrees about 2, 0. Well, let's see. In solving this problem, the examiners expect the well-prepared candidates to figure out the answer without constructing a diagram. So if the student is well prepared, the candidate will be able to just look at it and figure out the correct answer. And of course the correct answer is option C. But let us examine the options that we have. However, let us take a look at all of the options. We will begin by inserting the point and its image into the diagram. So let us put those into the diagram like we have them right there, no problem. So we have the point P01 and we have its image P prime 3, -1. Option A cannot be correct because in a rotation, a point and its image are the same distance from the center of rotation. Let us mark the center of rotation and it will be obvious that the point and its image are not the same distance from it. So the point which is the center of rotation is 2, 0, and we are just going to put 2, 0 right there. That's the center of rotation. What do we know? That this point, one horizontal movement, one vertical movement right there. What about the other one? 2 horizontal movements by 1 vertical movement. So we have here, we have 1, 1. For this one we have 2, 1. So we are sure that the 2 points are not equal distance from the center of rotation or the proposed center of rotation. Therefore, we are sure that it is not a 180 degrees rotation about that point. B. It is not correct because a reflection in a point and a rotation through 180 degrees about that same point are equivalent transformations. One is incorrect, so is the other. So we are sure that if one is incorrect, the other is incorrect because these two transformations that we have here are equivalent transformations. A glide reflection is a composition. As a matter of fact, we are looking at option C. A glide reflection is a composition of a reflection and a translation. Also, it is important to note that the line with equation y is equal to 0 is the x-axis. The line with the equation y is equal to 0 is the x-axis. And a glide reflection is a composition of a reflection and a translation. If the point is reflected in the x-axis, it may be located on a line perpendicular to the x-axis, the same distance from the x-axis as the original. Do not forget that in a reflection, the object and its image are equal distance from the mirror line, and the line joining the point and its image is perpendicular to the mirror line. So if we are reflecting this point in this mirror line, we are sure that it is going to be located somewhere on this line that is perpendicular to the mirror line. Well, this line is already perpendicular to the mirror line, so part of our problem is solved, and it is going to be the same distance away from the mirror line. So 1 unit up here, its image will be 1 unit down there, like that. This is how it should be on the opposite side of the x-axis to the original. So the image is going to be on the opposite side of the x-axis because the x-axis is the mirror line, and that is exactly as it should be. It is not difficult to see that a translation by 3 units in the positive x direction will take us to the image of B. So we are going to go 3 units in this direction. We can see 1, 2, 3. We are right there. The transformation is therefore a glide reflection. There we have it. Right there. No problem whatsoever. Since we end up at that same point, we are sure that C is the correct option. So the correct answer is option C. But we are not done yet. Let us take a look at the translation and prove that it cannot be correct. Option D is a bit vague, but let us say that it really should be a translation by the vector given. So, translation of the line 3, -1. I don't think that a translation should be described in such a way. Translation of the line 3, -1, and that is why it is vague. But let us say that it should really be translation by the vector, which is 3, -1. So, we will move from the original point 3 units in the positive x direction, followed by 1 unit in the negative y direction. We will do that and see what happens. So we will translate by the vector. The vector is 3, -1, 3 units in the x direction, positive x direction. Then we will follow that up by a movement of 1 unit in the negative y direction, which will be down, which is right here. So there is where we will end up. It is clear that the transformation will not take us to the image. Although it is close, it is not exact. In this case, a miss is as good as a mile. Mr. John buys a washing machine for $3,300, which includes a sales tax of 10%. Without sales tax, the price is, what do we imagine it should be? This is another of the problems that the examiners expect that students that are sharp on their numeracy will be able to solve in a second. It is not difficult to just look and see that the answer is option C. Alright, so that is the answer. We should be able to look and see. How so? Students who are sharp will be able to make a connection with an increase of 10% and multiple of 11. And of course 3,300 is a multiple of 11. So we are able, or we should be able, if we are sharp, to make a connection with multiples of 11 and also increase by 10%. Right, and the 33 that we have here in the 3,300 is a multiple of 11, so we are sure that the conversion to the original should be very simple. To increase a number by 10% will take it to 110%. 110%, you know, is 110 divided by 100. So 110 divided by 100 is 1.1. Therefore, increasing a number by 10% is the same as multiplying it by 1.1. The question is, what number was multiplied by 1.1 to give 3,300? Dividing 33 by 11, we get 3. It is obvious that the answer should be 3,000. Since the price is inclusive of the sales tax, it means that a number, say x, that we do not know, so we say x, was multiplied by 1.1. That is how we increase by 10%, as we have discovered. We multiply by 1.1. And the result is 3,300. So we increase by 10%, which is multiplying by 1.1, and the result is 3,300. Let us write this in an equation. That is how we do it. X, that we do not know, was increased by 10%, which is multiplying by 1.1, and the result is 3,300. So we need to find the value of x. Transpose in order to find the value of x. So we are multiplying by 1.1 here. Dividing through by 1.1 will cause the x to remain by itself on the left hand side, and on the right hand side we have 3,300 divided by 1. 0.1. And we will do that calculation on the next slide. There we have it. Let us divide by a decimal fraction, primary school style, multiplying the denominator by the power of 10. That will clear the decimal fraction. 10 will do. We will have to do the same in the numerator. So in primary school, we do not divide by a decimal fraction. We clear the decimal fraction by multiplying by the power of 10 that it requires for us to get rid of this decimal place. We have one decimal place, we multiply by 10. And we are required to do the same in the numerator. So if we multiply the denominator by 10, we will also multiply the numerator by 10. Like that. So we end up with 33,000 divided by 11. What do? We just, for a second, forget about the trailing zeros and say 11 into 33 is 3. And considering the trailing zeros, 11 into 33 is 3. Considering the trailing zero, we get 3,000. So 33 divided by 11 is 3, and including the trailing zeros, we have 3,000. And that is our correct answer, as we discussed before. We may take another approach to the problem in which we say that the price is inclusive of the sales tax of 10% and is therefore 110%. Remember that the original is 100%, to which 10% was already added. So that is how we end up with that 110%. The original is 100%, to which 10% was already added. We will proceed to find 100%, which will be the original. So we have 110%. That's what we have right there. And that is equivalent to $3,300. And we need to find what the original, which is 100%, is. But first we will go by way of 1%. So we will first find 1% by dividing by 110. So 1% will be 3,300, which is 3,300 divided by 110. So that is what the 1% will be. Without simplifying that, we may find 100% by multiplying this result, which is 1%, we multiply by 100 to get 100%. So 100% is equivalent to this that we have right here, which is this same one, multiplied by 100. And we may simplify by saying 0 will go with 0, and 11 into 33 is 3, so this is 30. So we'll have 30 here to be multiplied by 100, and that will give us 3,000. No problem with that. If John's present age is 3x years and Jane is twice his age, what will be the sum of their ages in 5 years' time? So we have the age of John and the age of Jane. So let us begin by considering John's age, which is 3x. And it is said that Jane's age is twice that of John's. Jane is twice his age. So twice means 2 times. 2 times 3x is 6x. In 5 years' time, both of their ages will be increased by 5. So 5 years down the road, John's age will increase by 5. Jane's age will be increased by 5. So we are going to add 5 to each one. So now we'll finish up by adding or finding the sum of their ages. 3x plus 6x is equal to 9x, and 5 plus 5 is equal to 10. So We add the 3x with 6x, we get 9x, and then we get 10 when we add these numbers. The correct answer is option B. Right there. PT is parallel to QS and QR is equal to RS. What is the ratio of the triangle, or what is the ratio of the area of triangle TQS to the area of triangle PQR? The first bit of information that PT is parallel to QS is given in order that we may see that the triangles are of equal heights. So the triangles are of equal heights. Right. And that is why it is said that this one is parallel to this one. If two lines are parallel, then the perpendicular distance between the two lines anywhere on the lines that you consider, the perpendicular distance between the two lines will be the same. And perpendicular is noteworthy because the height of the triangle is expected to be perpendicular to the base. So that gives us more power in solving this problem than we imagined in the first case. So the perpendicular distance between parallel lines will be the same all along the lines, and the base of the triangle is expected to be perpendicular to the height. No problem with that. And we have discovered already that so the heights of the triangles are equal. The other bit of information, namely QR is equal to RS, is given for us to see that the base of the triangle TQS is twice the base of triangle PQR. So it is said that what? QR is equal to RS. So QR is equal to RS. So that means, say for argument's sake, that this base is B. If this is B here, over here is also B, and the entire thing is going to be 2B. So whereas this is 2B, this one will be B, and the base of this triangle TQS will be twice the base of this triangle PQR. So the area of a triangle is dependent on two things: its base and its height. So the area of the triangle is dependent on only base and height. So area of TQS, we have that, and the area of PQR we have right there. The base of TQS is twice the base of PQR. So where we have the base, we put 2B for TQS and we put B for PQR. Why? Because this base is twice this one. And what do we know about the heights? The heights are the same. Right. So just by considering the products inside of the brackets, we realize that the area of TQS is twice the area of PQR. The ratio is therefore 2 to 1. So we can take a look and say, okay, if we're looking at the ratio, here we have that fraction bar here. We can think of an imaginary fraction bar here. If you have an imaginary fraction bar here, what will happen? H will cancel H, half will cancel half, B will cancel B, and we have 1 down here. So we'll have only 2 and we will have 1s. The ratio is 2 to 1. And the correct answer is option B. So the only difference is the base, of which one is twice the other. So we know that the area of one is twice the other. We could just take a look at the problem and determine that if the two triangles are of the same height and the base of one is twice the other, then the area of one will be twice the other. So we could have just looked at that and we could have discovered our answer in a matter of seconds. But just to make myself clear, I have gone through at length to explain. I do not imagine that candidates will go through length or go at length to do all of this. It is just the explanation that is time consuming. Arriving at the answer should be done in a matter of seconds.